Raising a Sunken Ship, Lab 11. Why does a ship float on the surface of water? Ships float because they are buoyant. Buoyancy is related to the density of the ship. A ship will float on the surface if its density is less than the density of the water in which it floats. Many ships carrying valuable cargo have sunk over the centuries. Some went down because great holes in their hulls let in water that decreased their buoyancy. Suppose you have been hired by a salvage operation that has discovered a sunken ship. The ship is not too badly damaged, and the salvage crew hopes to raise it intact. The rumor is that this vessel was carrying valuable cargo when it went down over 100 years ago. You might make a lot of money if you could get the vessel to the surface of the ocean. In addition, the historical significance could be incredible. You have some ideas on how to raise the ship, but you need to try them on a model first. In this investigation, you will try to raise a model of a sunken ship. Define density. How can a ship that weighs many tons float on the surface of water when the metal it is made of would sink if in a solid block? How can you change the buoyancy of a ship sunk in deep water so that it rises to the surface? You'll be provided with the following materials: a soda can, a 10-gallon aquarium, handheld air pump, plastic and rubber tubing in various lengths, crucible tongs and forceps, tape, clay, balloons, string, plastic straws, a balance, and a 100 milliliter graduated cylinder. Remember to quickly wipe up any water that spills to prevent slips and falls. You will want to observe the can at the bottom of the aquarium. The can represents a sunken ship. Working with your team, decide on a plan to raise the can. Because the sunken ship is supposed to be in very deep water, you may not touch this can with your hands or put your hands in the water until the can is at the surface. You may use only the provided tools and materials to get the can to float on the surface. What property of the can has to change before it can float to the surface? Write down your selected procedure on a separate sheet of paper. Have your teacher approve your procedure before carrying out the investigation. Follow your procedure to float the can to the surface. After the can floats to the surface, remove the can from the water and dry it. Find the mass of the empty can and record it in your data table. Fill the can with water and find the mass of the full can. Record the value. Next, you'll measure the volume of the water in the can using the graduated cylinder. If the amount of water is more than 100 milliliters, measure the first 100 milliliters, empty the graduated cylinder, and measure the remaining water. Add the numbers and record the volume in the data table. If the volume of water in the can is, say, 350 milliliters, what is the volume of the can when it is empty? That is, when it contains only air. Calculate the density of the can when it is empty. Calculate the density of the water-filled can. How did the densities of the empty can and the water-filled can compare to the density of water, which is 1.0 grams per milliliter? Would you expect the empty can to float on the surface? Give a reason for your answer. Use the data you collected on mass and volume to explain why the water-filled can would sink. Would you expect a can that is half filled with water to float on the surface? Use the data you collected on mass and volume to solve this problem. Calculate the maximum amount of water that the can could hold and still float on the surface. Now, to barely float on the surface, the can and the water must have a density slightly less than the density of water, which is 1.0 grams per milliliter. We will complete this lab in class, and you should file it in your binder.
Are we allowed to touch the water like the surface?
Can't get your hands in the water until the can's at the top. That's the tricky part.
You can push it inside.
Pulley system, so we're gonna wrap it around the.
And we're gonna have a tube that goes down. Half of the balloon is gonna go inside. What
in the world?
We're gonna blow it up so that it like locks in place, and we're gonna pull it up.
Okay.
And if we need to.
What if we tape our pencils to it to get around the reach? Okay, here we go.
All right, I want to see this. This is, yeah.
All right.
Let's do it.
Okay, lower it.
Oh my, okay.
Oh geez, look at that.
And you're going to try and get it in there.
Up. Bit more.
There.
To left. Forward and forward. As hard as you can go. Forward. Nope, it's out. Balloon's still in. No, just float. Nope, never mind. It's out.
Got it. All right.
Do that, and I'm gonna slide the tube. Other side. You got it.
There you go. That's a good idea.
And up. Forward.
Look at that.
I think I know how to do it. Maybe.
Just a tiny bit. Forward.
Forward.
You gotta get the very end.
This will work, no matter how long it takes.
Wow.
We can grab the can.
Look at it.
Grab the can.
Quick.